Hello everyone, welcome back. Today's topic is in vectors. Today we're going to learn how to resolve a vector into components, but we're going to learn how to get those component formula from the graph. So we have a vector. I have drawn the vectors already here. Vector v pointing at these directions, and the angle measured is theta. The angle is measured counterclockwise. So we need to resolve this vector v into y-axis and into x-axis to get each y component and x component. So according to the formula that you'll see in your book, you will have if you resolve that vector into your x-axis, you'll get v cosine of theta, and if you resolve that into y-axis, you will get vector v sine theta. Okay, that is so for the formula that you'll see in a book. But let's try to understand how we wind up having that formula as of your component vectors. So let's get back to trigonometry. Let me draw a triangle here. Yeah, okay, triangle here. So this triangle, this will represent my vector b, and this is represent my theta. It's sort of like just the picture was not mirrored, so it's reflected on a y-axis. It's the same thing. So we have vector v, we have theta, but then we all know how to get missing sides. So this side is missing and this side is missing. So let's call this triangle A, B, and C. So in triangle ABC, what is really happening here is we have one angle, we have one sides, and we need to find the rest of the sides. So how do we do it? So to find AB, we need to get a ratio of one trigonometric expression, including theta. So we already know V, which in my case is hypotenuse. So we have a theta, we have hypotenuse. So the only trigonometric expression that allows me to use AB and AC together would be sine theta. So I'm going to write sine theta. Okay. Equal sine theta is hypotenuse over perpendicular. So we have AC over AB over AC. It's perpendicular over hypotenuse. Okay, so sine theta equal AB over V. So AV is vector V sine theta. Okay, so far so good. So we found AB. Let's try to find BC. So we have AC and we have BC. Since we already know what AB is, we can use AB, but let's try to stick with AC and let's try to find BC. So we have AC and we have BC. So the expression that we can use to include those two quantities would be cosine of theta. So cosine of theta would be base over hypotenuse, AC. Okay, so in that case my BC would be AC, which in my case AC is vector V times cosine of theta. Okay, so we have found two terms here, BC and AB. Excuse my writing, I'm trying to use mouse. In a later video I will try to use stylus, so the writing will be more precise. Here we have AB and we have BC. So AB represents the y component of my vector here. This would be my y component. My BC represents x component of my vector. So basically the so-called formula that you would see in your book with no explanation was nothing more but the triangular missing portion that you could have derived by yourself using Pythagoras theorem. So that's how you resolve your vector into y component, which is here, and resolve the same vector into x component. So reverse scenario, if you have x component and y component of a vector, you can find resultant vector using this formula: v cosine of theta square plus v sine of theta square under the radical, and you have your resultant vector, which is the same vector we started with, which is vector v. Thank you for watching. Please leave me a comment, and please don't forget to subscribe to my channel for more videos in multivariable calculus. Thank you for watching. Have a good day.